All right, welcome to the test review on factoring. Let's get right into it and attempt the first problem. So the first problem is 24st minus 32t squared. It does not appear to be a difference of squares, but as always, the first step we should take in any of these problems is to factor out the greatest common factor. So what's the biggest number that divides into both 24 and 32, and that's going to be 8. Both terms do not have an s, but both terms have 1t, so we can factor that out. And what we're left with is 24 divided by 8 is 3. S and t divided by t cancels, and so minus 32 divided by 8 is 4, and t squared divided by t is t. Remember that we can always double check our work by distributing back out. That should take us back to the original problem. For people who want a further breakdown of the problem, if you don't want the further breakdown, feel free to skip through to the next problem. Another way to think about it is 24 is 8 times 3, which is 2 times 4, which is 2 times 2. And 32 is 8 times 4, which is 2 times 4, which is 2 times 2. And then t squared is t times t. So what are the common factors? What are the factors we see in each? And the answer is 2, 2, 2, and 2, and t are the common factors. And there, if we multiply that out, is our 8t. And then let's think about what's remaining. Over in the first problem, there's a 3 and an s remaining. In the first term, I'm sorry. And in the second term, there is 2 times t remaining. So that, once again, comes out to the 3s minus 4t. Now, I don't expect you to necessarily do it this way on the test. Hopefully we're good enough at this point of pulling out the greatest common factor. We don't have to resort to that. So for this one, there is no greatest common factor. And it's a third degree, and we weren't given a hint. So our best guess to start with is to try factoring by grouping. And so out of the first part of this, I can factor out a 3x squared. And what's left is 4x plus 5. Now notice that in order for factoring by grouping to work, what winds up here and what winds up here has to be the same. And right now, this one has a negative and a negative. So I can factor out a 2, but I'm going to factor out a negative 2. And that's going to change the signs of what's inside the parentheses. Since now 4x plus 5 is a common factor of both terms, and that gets factored out front, and what's left is 3x squared minus 2. For the third problem, it's a second degree trinomial, and we need to factor out, if possible. So since there's a number in front of x squared, we're going to use our old technique where we say a is 2, b is negative 3, and c is negative 9. So a times c is negative 18. So then we look for things that multiply together to give me negative 18 that add up to negative 3. And in this case, those two are going to be negative 6 and 3. Negative 6 times 3 is negative 18. Negative 6 plus 3 is negative 3x. So that's our guidepost for what we're going to do next, which is we are going to split the negative 3x into negative 6x and positive 3x. And then we are going to factor this by grouping. And out of the first term, we can factor out a 2x. And what's left is x minus 3. the second term we can factor out of 3, and what's left is x minus 3. And we'll be left with 2x plus 3 times x minus 3. Or, actually, let's go ahead and write it. And once again, order doesn't matter, but since that might have confused some people, the common term, x minus 3, are right out front. And the remainders, the things that were not factored out, are 2x plus 3. Remember, when we're multiplying, order doesn't matter. So both of these two expressions are the same. All right, for number 4, we look at this. All right, it only has 2 terms, so we ask, is it one of our special binomials? Is it a difference of squares, a difference of cubes, or a sum of cubes? And looking at it, I see a whole bunch of squares. So this is, in fact, a difference of squares. So the square root of 36 is 6. The square root of a squared is a. The square root of 16 is 4. And the square root of b squared is b. And we're just going to write it out in the 2 pieces like that. By making sure that one of the terms has a plus in the middle, one of the terms has a minus in the middle, when we FOIL, the outside and the inside terms will cancel out, and we'll just be left with the 2 ends, which is the difference of the squares. All right, for this one, I really don't like having a negative out front. It makes this problem very difficult for me. So what I'm going to do is I'm going to factor out a -1 and just change the signs on everything. That, to me, I find a lot easier. Now I'm just looking for 2 things that multiply together to give me -18 that add up to +3. And that's going to be 6 and -3. Now, because there's nothing in front of r here, I can just write it out as this. Now, once again, order doesn't matter. Now, a word is on the SOL. They may not pull out this -1. And so you may see it written like this. Oops, sorry. That was incorrect. So they might multiply the -1 into one of the terms. So you may see it written like -r minus 6 times r minus 3. Or you may see it, they may multiply the -1 to the second term, and they write it -r plus 3. It's important to remember that all 3 of these are equivalent statements. All right. Now this one looks like it's going to be an AC problem, and it is. But before we start that, remember our first step is to always see if we can pull out a greatest common factor. And in this case we can, and that's nice because it makes AC just a little bit smaller and makes it easier to find my pair of numbers, which are going to be +7 and -2. And so I will split the 5x into -2x and 7x. And then I will group the first 2 and the second 2 terms and factor those out. So I'll have my 3 times the quantity 2 times x minus 1 plus 7 times x minus 1. Or 3 times x minus 1. This should have been, sorry, I should have factored out a 2x here. Times 2x plus 7. So sorry about that mistake right here. That should have been a 2x that was factored out. And now that is fully factored. For this one, once again, special binomial. So what is the form? Well, this is a cube, and the second term is a cube. So remember, 2 terms, 3 terms. In the first 2 terms, they're the cube roots of the 2 terms from the sum of cubes. So 8 cubed is 2. Then, this is A. So we will square the first term, multiply the 2 terms together, square the second term. Then to find the signs, we just remember the acronym SOAP. This was a sum of cubes, so the first sign is plus, then because that's S stands for same. The next sign is negative because the O stands for opposite. And the last sign is a plus because this stands for always positive, as we went over in class. All right, number 8. So, first step always, can we find the greatest common factor? And we can factor out a 2. But now we run into a problem, because now I'm looking for 2 numbers whose sum is -5, but whose product is -1. And those 2 numbers don't exist. So this part of the expression now is prime. The whole thing is not prime because we were able to factor out a 2, but that's as far as we can take that problem. Number 9. Once again, it's a binomial, but as we said before, our first step always has to be to pull out the greatest common factor. Notice both terms are divisible by 2, and both terms have at least 1 x, so we can pull out 2x. And what's left is x squared minus 4. But we don't stop there because this part here is a difference of squares. So it can be broken down further as x plus 2, x minus 2. This is a difference of cubes. So once again, 2 terms, 3 terms. The cube root of the first term, the cube root of the second term. And we call those A and B. And the 3 terms in the second part of this is A squared, A times B, and B squared. So A squared is going to be 4x squared. A times B is 2x, and B squared is 1. And then to get the signs, we just go back with SOAP. Same, whoops, sorry, that's not the same. Same, opposite, always positive. All right, this one looks a little challenging. But remember, always pull out the greatest common factor first. So I can pull out a 2, and I'll end up with x squared minus 8x plus 16. So now I need 2 numbers that multiply together to give me positive 16 that add up to -8. And those 2 numbers are -4 and -4. So I end up with 2x minus 4 times x minus 4. But what we'll notice is this and this are the same, so we really should write this as 2 times x minus 4 squared. Number 12 is a trap. This is the sum of squares. And this is prime. And the reason it's prime is a lot of students want to try and either do this But if I FOIL this out, this is x squared minus 16. Or they want to tell me that it's this, x plus 4 times x plus 4. But if I FOIL this out, I get x squared plus 8x plus 16. So there is no way to factor a sum of squares. It is always prime. All right, number 13, no common factor, so we're going to have to go a times c, which is 90. So I need two numbers that multiply together to give me 90 that add up to negative 23. And since, remember, when we're stuck, we can just start listing all the factors. Now, the key here is that they add up to a negative number, but they multiply together to give me positive. And that means both numbers have to be negative. And then we look for the pair that adds up to negative 13. And so we're going to write this as 6x squared minus 18x plus negative 5x. So I split the 23x plus 15. And then I group. And out of the first term, I'm able to pull a 6x, and this is what's left over is x minus 3. And out of the second grouping, I'm going to pull a negative 5. And that's going to change the signs of the stuff inside, but then we'll cause those to be the same, and so we will get x minus 3 times the quantity 6x minus 5. There's two ways to do it. One is you could recognize the form. If you have a plus b squared, it's always going to be a squared plus 2ab plus b squared. A lot of us have a lot of trouble recognizing that form. So if we don't recognize it, we're okay, because we can just factor it out. So a times c is 100. So I need two numbers that multiply together to give me 100 that add up to negative 20. So let's start listing out the factors. 1 in 100, 2 in 50, 4 in 25, 5 in 20, and 10 and 10. Now the key here is that because they multiply together to a positive and add up to a negative, they both have to be negative. So the pair we're looking for is negative 10 and 10. So 4x squared minus 10x plus, sorry, I always like to write the plus, negative 10x plus 25. So we split negative 20x this way. And out of the first term, we'll factor out a 2x, and that leaves me 2x minus 5. And out of the second one, I'll factor out a negative 5, and that leaves me 2x minus 5. Because when I factor out a negative, the signs change, and I'll end up with 2x minus 5 times 2x minus 5, or 2x minus 5 squared. All right, number 16, we're given a hint. So what we do is we divide the entire expression by the given factor. And it should divide in evenly. And so if you've forgotten your long division, what multiplied by x would turn it into x cubed? Well, that would be x squared. And so we multiply x squared by what's out front, and I'll end up with x squared plus 2x squared. And then in long division, we subtract, and we'll end up with x squared. And I bring down the minus 10. X. minus 10x. And so then I'm going to multiply by x, because x times x will give me my x squared. So x times x plus 2 will give me x squared plus 2x. And then I subtract. Remember, I'm putting these parentheses because I'm subtracting everything. So this is x squared minus x squared and negative 10x minus 2x, which will give me negative 12x. And then I bring down the negative 24. And so to turn x into negative 12x, I'm going to multiply it by negative 12. That'll give me negative 12x minus 24. And my remainder is 0. So at this point, we know that x plus 2 times x squared plus x minus 12, this expression is equivalent to the original expression. So, but is this fully factored? Can I factor this at all? And the answer is yes, I can. Two numbers that multiply together to give me negative 12 that add up to positive 1 are positive 4 and negative 3. All right, now I'm going to show you one more problem, but as tough as we can, almost as tough as we can make one, that is a little bonus question. So let's look at this. Let's see, is there a greatest common factor? Well, yes, I can pull out a 2x. This will give me 6x squared minus 2xy minus 4y squared. So now what do I do? Can I factor then this lower part? And the answer is yes, I can. Once again, I know the y squareds freak us out in the y's, but they're the same relationship as the x's and the x squareds. So let's just go with a times c is negative 24. And those negative 24 needs to add, product of negative 24 needs to add up to negative 2. So the numbers are going to be negative 6 and positive 4. So what I'm going to do is I'm going to split the negative 2y into the negative 2xy into negative 6xy and positive 4xy. And then I'm going to factor by grouping. So I have the 2x out front. Out of the first term, I can pull out a 6x. And what's left is x minus y. And out of the second term, I can pull out a 4y. And what's left is x minus y. Once again, this is a bonus problem, so don't stress out 100% if we don't get this one, even though it's very doable. All right, if you have any other questions, come prepared to ask them before the test.